and we'll be working with this packet right here. We're going to talk only about scientific notation today, and we may do the majority of it today, and then the last 2 pages of this packet, I think I want to wait till tomorrow to do that. Okay, but I'll do enough that you guys can do everything except page 7 and 8 in the packet. Definition of scientific notation. It's some number only 1 to 9. It can't be 10. It can't be a 2-digit number. It can't be 0. Okay, something 1 to 9 times some power of 10. Now I gave you some examples here. This, see the number in front of the decimal? It's something 1 to 9, okay? Times 10 to some power, okay? Here again, the number in front of the decimal is 7, that's 1 to 9, times some power of 10. Now we can have a negative exponent or a positive exponent. We're going to show you how that works. Okay, this is called scientific notation right here. Now over here, I gave you an example of what is not scientific notation. Although it is 10 to some power, the number in front of the decimal is 23. That's too big. So this is not in scientific notation. Do y'all understand? Okay, so here's what we're going to do. A lot of people, when they're trying to change back and forth from scientific notation to standard notation, they like to think, okay, when I'm changing it this way, I move to the left. And when I'm changing it this way, I move to the right. Well, let me just get there and I'll explain. Okay, let's just go straight to your worksheet because I found out it's just easier to explain with one of your problems. So we're looking at the first 2 pages in here are reference pages for y'all. It just tells you how to change from standard form to scientific notation. And then page 2 tells you how to change from scientific notation back to standard form.
Hey, Miss Deborah.
Yes.
I don't have those 2 papers. I have all the worksheets. I've got like 8 worksheets, but I don't have those 2 papers to have those definitions on them.
Really? Okay. I will get those to you afterwards. All right.
Thank you.
Okay, I will explain what's on there. All right, we're going to take something that is in standard form and change it to scientific notation. Okay, so the way you do that, and I'm going to take one that's farther down because now I'm going to give you some examples, so don't worry. All right, let's take 787. Okay, this is called standard notation because it's not, I mean, it's just normal. That's what I call normal. Okay, it's not in scientific notation yet. So the way that we're going to change it to scientific notation is, first of all, we need to understand where the decimal is in a standard number. If it's not showing, it's always at the end. This is where the decimal is. It's lots of invisible stuff in algebra, right? And so if the decimal isn't showing, it's always at the end. Now, where do we want it to be?
Behind the first 7.
Behind the first 7. It needs to be here, okay? So we are going to move this decimal to that place. But as we move it, we need to count how many spaces I move it to. So I'm going to move 1, 2 spaces to get it to where it belongs. Do y'all see? Now I'll show you why we have that too. So I'm going to write this again as 7.87, and that's good. But because I moved the decimal, I have to multiply it times 10 to the second power. 10 to the second, that's where the 2 comes in. I moved it 2 decimal places. Everybody good? Okay. Now I'm going to jump immediately to the other one. What if I have point This is also, I don't think I want that. I'm going to put another 0 here, guys. Just because I don't want to mix you up. Okay. 0.00314. Okay. And I want to change this to scientific notation. So where do I want the decimal to be?
Behind the 3.
Behind the 3, that is correct. Because when I move it, these zeros don't matter anymore. So 1, 2, I moved it 3 places. So I'm going to write this number down. And I have to have 10 to some power. Now, here's what I want you to try to wrap your head around. This is going to be -3. Now, sometimes, this is where I was talking about left and right. I think that it's easier to remember this way. If you started with a tiny, tiny number, and you know, if you had this much money, you don't have much money, right? So this is a tiny, tiny number. If you start with a tiny number and move to scientific notation, you need a negative exponent. Okay? This is large number that we started with. I'd like this many. Okay? If I start with a large number, I need a positive exponent. See? I think it helps so much better than left and right, because when we go to the next part where I'm taking these and moving back to standard, then left and right becomes extremely confusing. Okay, if you try to just memorize left and right. Okay, everybody okay? So remember, if you start with a tiny, tiny number changing, you're going to use a negative exponent. If you start with a large number, you're going to have a positive exponent on the 10. And then the number just comes from how far you move your decimals. So now we can go to the worksheet. And we'll do more. That's only one example. You'll get plenty of practice. So number 1A says 5.7, and the instructions say write each number in scientific notation. Okay, so the very first thing you're going to look at, how far do I need to move the decimal to make sure that it's in scientific notation?
You don't.
I don't.
So you just put times 10.
5, if it's times 10, that's 10 to the first. That means I moved it 1.
Oh.
So this one is going to be 5.7, you were close, times 10, but I didn't move it at all. But scientific notation means you still have to have the 10 to the power. You have to show it to be scientific notation. So even 10 to the 0, let me make sure that's what they're doing. Yes. So if it's already where you want it and the decimal is in the right place, you're not moving it at all, you still have to have the times 10 to some power. Everybody okay?
So do we have to put the power on here?
You have
If
to.
it's 0?
Mhm. Now the 10 to the first, you can or not put the 1. You have to put the 0, because 10 to the 0 isn't 10. It's actually 1. Remember, anything to the 0 power is 1. So we're doing 5.7 times 1 is what we're actually doing. But scientific notation says I have to have some power of 10. Okay? Let's do the next one. 2A looks like this. And this also says to change to scientific notation, okay? So where does the decimal need to be?
Behind the 5.
Behind the 5. So I'm going to move 1, 2, 3, 4, 5 places. So I've got 5, and you can put 0.0 if you want, because afterwards you can put as many zeros as you want. You see? times 10 now.
Power of 4. Right?
1, 2, 3, 4, 5.
Okay, power of 5.
And I started with a T90 number. -5. Because I started with a very, very, very small.
Yeah.
Okay?
Okay, so zeros go until you get behind the number
Yes,
itself, and
yes.
then that's how many.
That's how many.
Okay.
How many loops you have. You start here. 1, 2, 3, 4, 5. Okay? And since it started a little tiny number, we've got to make it a negative exponent. Okay? I had trouble with scientific notation, and that's why I'm teaching it this way. Because I always try, my teachers told me about left and right, and man, I got messed up bad. So I just came up with my own way, like I do a lot of stuff. All right, let me look down and see if there's one more that I want to do off this page. Then we'll go backwards. Let's do, nah, not necessarily. I'm gonna go to the next page. Okay, now the next page gives us scientific notation, and they want us to change it back to standard. So you're gonna have to remember which way to move your decimal, okay? And we'll talk about this. So 1A says 6.5613 times 10 to the -3, okay? Here it is. And we know this is in scientific notation because the 6 is here and we have 10 to some power. So this is scientific notation. We're going to change it to standard. Now remember, if we have a negative exponent, that means we need a tiny number, right? So we need to move the decimal 3 places this way. 1, 2, 3. Now notice there's no numbers there. And if there are not, we put zeros in it. And so this would be your answer. Oh, without this. Okay, you take the power of 10 off after you move the decimal.
So you, oh, okay.
It was -3,
Okay, I
and
see.
it was right here.
Yeah.
1, 2,
Okay.
3. You have to remember that the negative means little tiny number, and the positive means big number.
Okay.
Is this making sense to y'all? Okay.
Yes.
Let's look at, wow. Okay, let's look at number 13A. (13A) gives us scientific notation, 7.4055 times 10 to the 0. So tell me what the standard form is for this.
7.4055.
You're exactly right, because this says I'm not going to move that decimal at all. So my standard is 7.4055. Now remember, standard doesn't have the times 10 to the any power. So this would be the standard form because we're not moving the decimal at all. Are we good?
Yes.
Is everybody feeling pretty comfortable? Okay. You guys, I just watched that go dark.
Oh, did you?
Yeah. Mike. There it goes again. I wonder if I'm not plugged in very well. Okay. Now let's go to the next page. Let's do this one. We're back. I told you I went back and forth.
Yes.
So now they're going to give you standard form and they want you to change to scientific notation. So let's look at 1A. And we have 4,097. And I want to change this standard form to scientific notation, okay? So I'll give you a second.
So
put the 0 before the 4, for 004.
This one? The decimal needs to go all the way up to here so that the number in front of the decimal is between 1 and 9. Okay? So it has to come all the way here, and this is where it is if you don't see it anywhere. Okay? So we're going to start from where it is. 1, 2, 3, 4, 5, 6, 7. We need it to be here because the number in front has to be between 1 and 9. Okay? So for scientific notation, we're going to have 4.4004097 times 10 to the
7th.
7th. Good, Josh. 7th, because it was a large number to start with, so I need a positive exponent. And I moved 7 places. Everybody good? And let's do 9A. 9A. Nine A says 33. Change this to scientific notation.
Be
Sandra?
3.3 times 10.
To the first.
To the first, yes. So it's going to be 3.3 times 10 to the first. Because the decimal's here, it was a larger number. And so I had to move it one place.
And always start from the back to the front.
Yes, yes. If you don't see a decimal, it's always from the back to the front. Yes, ma'am. Good question. Well, if the decimal isn't showing, yes. So do we feel comfortable enough for the first 4 pages? Good. Okay. Oh, here's another one. I haven't done the 4th page, I guess. Let's do this one. This is the next page, page 4. I thought we had already done 4 pages. Let's do I'm doing 8A. Here's the scientific notation. And I want the standard notation. It's a positive exponent, so I'm going to have a big O number when I'm done. I'm going to have big money.
Add 2 zeros behind a 7.
You are exactly right. Josh, I think you've got it. By George, I think he's got it. Do y'all see you're going to have the whole number and 2 extra zeros? Because we're going to move. We've got to move big. So 1, 2, 3, 4, 5, 6, 7, 8 means I have to add those extra zeros in. Questions on this so far? Do you think you're okay?
Piece of
After
cake.
practice. But you've got the idea, right? Okay.
Do one more on this page.
Do some more on that page?
Yeah, just,
Pick one.
let's try this on 14A.
14A. Does everybody have this one? (14A) 7 .080404 times 10 to the 7th power.
Okay, on that one,
You'll add 1 0 on the end.
right, 7, and then add a 0.
Yes, you got it. Perfect. Perfect. So it's going to be 7080404 because 1, 2, 3, 4, 5, 6, 7. So I need that extra 0 right here.
Yeah.
Better? Okay. Let's go to the next page. Now, this is the reason that you learn how to do scientific notation. And it's also why I already taught you the rules of exponents, because now we're going to put the two together. So I'm going to use the example that's on the page. Now they want you to take 6 times 10 to the 3rd times 2 times 10 to the 5th. Okay, this is a lot easier than it looks because you don't want to change this to standard and then change this to standard because, man, it gets nasty. Okay, so here's what you do. When everything, see the times, everything's times. So when it's all multiplication, you can move this stuff around however you want to. So let's put the numbers together. And then the powers of 10 together. We've just regrouped, and you can do this as long as everything is multiplied. You can change the order. Okay, now remember that because tomorrow when we talked about page 7 and page 8, there's pluses and minuses, so it's going to be done a little bit differently. But as long as it's all multiplied, you can rearrange those. Now all you have to do is 6 times 2 is 12 times 10. Now remember what we said, if we have same bases multiplied, what do we do with the exponents?
You gotta do it 3 times. No.
Add.
Add. We add the exponents. So if we have same bases and it's multiplied, then we add the exponents. So I have 10 to the 8th. Now, this looks like scientific notation, but is it? This is 12. It can't be 12, right? So what we're going to have to do, and you need to think on this, what we have to do is move it, the decimal's right here, we have to move it one more place than what it is, right? So if we move it one more place from here to here, I started with a large number, so I have to add one more decimal place. You see, when I moved it that one more, it was a large number, larger than 1, right? So it was a large number, so I had to add an exponent. So now the answer to this is 1.2 times 10 to the 9th power. Do y'all see? I had to go ahead and change this because it's not actually in scientific notation yet. You see? Okay. And I knew to add 1 because I started with a bigger number. So I add 1. If I started with a tiny number and had to move the decimal, then I would have subtracted 1. Well, I'll see if I can find one. Is this making sense? Because believe it or not, we're almost finished. Is that good news? I can only take so much. Let's do the other example, and then I'll take some off of this page. I think you have several pages. I think you have 2 more to do these kind of things. Here's an example with division. 18 times 10 to the 6th divided by 4 times 10 to the 4th. Now again, we don't have to change these to standard form, okay? What we do first is we find out what this is, and when it's divided out, it says on our example that it's 4.5. You would just do that on your calculator, 18 divided by 4, because this is a fraction in itself. And then we look at the powers of 10. If the bases are the same and they're divided, what do we do with the exponents?
Subtract.
Right.
So I have 6 minus 4, so I have 10 second power. Now, it's going to be really important in these type of problems to look at your answer and make sure it really is in scientific notation. Is it?
Yes.
Yes, because the number in front of the decimal is between 1 and 9. So everything's okay. We don't have to. Okay. Well, actually, it didn't move at all, because when you take 18 and divide it by 4, the answer is 4.5. So we just wrote down what the answer is. If it was 0.45, then we would have had to move it.
Is that because it's a fraction?
Yeah, lots of times the fractions will come out whole, like 17. And then you would have to move it to 1.7. It'll come one at a time. Okay, but all of these, it looks like is there one, look on that page, is there one you want me to do? And then we'll look on the next page. Number 1, okay? Okay. Now we're going to look at this carefully, because later on we know there might be pluses and minuses. But this time there's times, times, times. It's all multiplied, so we can move this around all we want to. Let's put these numbers together. So we've got 7 times 9 times 10 to the 8th times 10 to the 6th. So we can do these and then these, okay? And if you calculator or know your math, times 10 to the, and we add the exponents, 14. Okay? But we always look at our final answer and see, is it really in scientific notation? It is not. So I'm going to have to move the decimal from the back, because it's invisible, and move it one place to make it 6.3 times 10. But if I move again, I've got to do something to this. I'm going to add or I'm going to subtract from this 14. Add 1, because I started with a bigger number. And so I'm going to add 1 and make it 6.3 times 10 to the 15. Guess what? This is all we're doing today. Yes. Let's look at the next page to make sure and see if you have any questions on the next page. This has to do with the negative exponents. We better do some on here. We better do a multiplication one and a division one with the negative exponents. It's still the same rules, but sometimes the negatives get weird. Josh, Sherry, Irene, are you with us? Is everything okay?
Oh, yeah.
Yes, ma'am.
Okay, Irene? You have to move away from us for a minute.
Oh,
Oh, you're just on mute. Now you're unmuted.
oh,
You doing
oh,
okay?
shoot. Yeah, do you hear me?
Yes, I do. Are you following everything?
Yes,
Okay, all right. We're on page 6. It's this one. Up at the top, it says multiply, divide, MS1. Okay,
okay.
all right. So let's do, no, I want to do, okay, number 1. We're going to do this the same way, but it involves negative exponents. So I want to make sure you see this. All right, again, multiply, multiply, multiply. We can rearrange them all we want to. Two times 9 is 18. 10. Now remember, we still add the exponents because we're multiplying same bases. So we add the exponents, but now we're adding a negative, which actually is like subtracting. So 7 plus a -3 is 4. So be careful about your negatives. 7 plus a -3 is 4. Check your answer. Is it scientific notation?
No.
No, it's 1.8 times 10
of power
Mm,
5.
yeah.
Yes.
to the power of 5.
Yes, because we moved here, we started with a bigger number, so I have to add. If we started with the bigger number. So I have 1.8 times 10 to the 5th. Be very careful of your negatives. Now, adding negatives, we're pretty good at that. We better be really careful on the division. Let me show you number 2. Okay? And all it is, you guys know how to do it, it's being careful. If you're going to deal with negative exponents, just slow down a little bit. Okay? Number 2 says 15 times 10 to the -5th divided by 4 times 10 to the -7th. So, since it's all multiply and divide, I can do this part and just divide this out. I think it should be 3.75. Would y'all do it? Okay. 3.75, okay? Times, and now if we have same bases, we're going to subtract the exponents. Now you've got to be very, very careful here. We're going to subtract the exponents. So I'm going to take -5 and subtract -7. Do you see the double negatives here?
You're gonna add it.
We put this minus this. So this becomes a plus. -5 plus 7 becomes 10 to that. Okay. Becomes 0.75 times 10 to the 2nd. Okay, because I have -5 plus 7. Y'all see, when we're dividing, we're taking this one minus this one. So you have to have the minus and the negative. When you have a minus and the negative together, it turns into a plus. So -5 plus 7 is 2. Check your answer. Check your answer. Is it in scientific notation?
Yeah.
Yes, it is, because 3 is between 1 and 9. We're good. No, times. That's
Oh,
times.
times, yeah.
I took 15 in the calculator and divide it by 2. This, the fraction line always means divide. Okay, good. Oh, yeah, yeah. It's, you don't want to add these. We are subtracting them now because it's divide. We have to subtract the exponents. Everybody clear with that? Just when you come to problems with the negatives, you know how to do them, just slow down. All right? And of course, ask questions. How are we doing remotely?
All good.
Good.
Irene, it's so special to see your face.
I miss y'all so much.
We've been going crazy.
I know I've been a ghost and it's not because I want you, but it's my
Yeah.
health is really throwing me down.
Oh, you made my day. I love you guys. I know everybody has stuff going on. I was talking about that this morning. Every one of you has major stuff going on, and you still come to school. I'm amazed at you. I think all of you need gold stars all over the place. You're amazing.
I miss you so much, guys.
I haven't had a request for number 7. Four times 10 to the 8th divided by 1 times 10 to the 4th. Okay, and so we can separate this again, and we can say, what is 4 divided by 1?
4.
And now we're going to do our tens. Dividing same bases, we subtract the exponents.
10 to the 4th power.
Yes, sir. We know that if the decimal's not showing, it's right here. And you can put a 0 if you want. You can put as many zeros after if you want. But the decimal is here, and what's important is what's in front of the decimal. And it's just a 4, right? So this is scientific notation. Is that okay, Mary? Just make sure that you're not trying to do these problems by changing this all to standard form, change this all to standard form, and then try to do it all in your calculator. Blah. Perfect.
Can you use that one?
Yes. Here's the problem right here. And so I did the numbers. I call these the numbers and these the powers of 10. So I decided just to do this fraction right here. This line in a fraction always means divide. So I took 4 divided by 1, and that gives me 4. And then when you're dividing same bases, which is the 10, we're dividing same bases, we subtract the exponents. So I put the base down, and 8 minus 4 is 4. Then I looked at it and I thought, well, is that scientific notation? It didn't have a decimal at all. But if it doesn't have a decimal, it's at the end, right? And so it would have been here, which is the proper place for scientific notation. Questions on that, Brandy? Not sure yet. Okay. Any more? This is as far as I want you to go. The first 6 pages, 7 and 8 tomorrow. And I'm not sure how much I'm going to spend on 7 and 8 because I don't think, pretty good chance you're not going to see that kind of problem. So I'll decide between today and tomorrow if we're even going to spend much time on it. All right. So how about you guys online? Everything okay?
Yeah.
Yes, ma'am. I
You
just
feel
gotta
like
go
you-
back and find page 5 somehow. I know that it got left out of my packet. I gotta go look for it in my email.
Page 5 did also?
Yes.
Those
It
first
might have
2?
just been, it might have just been me. But I'm gonna go back to my email when we get off and look for it.
And if it's not there, tell me, I can send it in a GIF.
Okay.
I'm finished. Everybody can stay if you want.